All right, let's do chapter 1.5, which is about continuity and the intermediate value theorem, IVT. The homework is broken into two parts, creatively called part 1 and part 2, and so the class videos are broken into two parts, so we're going to start part 1 now. This chapter is about continuity, or a function being continuous, and let's just try to get our imaginations going here. What does continuous mean without giving a definition at all? Here's a bunch of functions. Which of these would you say is continuous and which of them are not continuous or discontinuous? So pause the video, think about which ones you would classify as continuous or not, just based on that name. All right, welcome back. So that one is continuous. It's all one piece, you could say. How about that one? Yep, that one. Yep, all these are all one piece. Well, that one, that's piecewise linear, but it connects right there, so that's good. So it turns out the continuous ones here are mostly in the left and upper side. So here's the dividing line. All those are discontinuous, or not continuous, and all these over here are continuous. So based on that, that separation, let's give an intuitive definition, or how would you say, based on this, how can you characterize what's continuous and not? So the intuitive definition we usually give is that a function is continuous if you can draw it without lifting your pencil or pen from the paper. So for example, here the sawtooth wave, you have to lift your pen up to go to the next start of the sawtooth. Here where there's a hole, I know technically you could swing your pen or pencil around the hole and keep going, but really what we mean is you would have to lift your pencil up and then put it back down on the other side of the hole. So that's the intuitive definition. Let's try to come up with a technical definition. We know we're in the chapter involving limits, so what can we say about what limit things are going on here? We'll say f is continuous at some horizontal position A if and only if what? Something about a limit. So we could say the limit as x goes to A, that horizontal position A, of f of x equals f of A, which seems like a fairly straightforward statement, but there's actually three big things going on there. For one thing, even before we get to those three things, if and only if means that if we are told the function is continuous then at A, then this is true at A. And if we find that this is true at A, that means the function is continuous at A. It works both ways. One thing that's hidden here is that the limit has to exist rather than D and E. Part B is that the function value at A has to exist. Not being undefined, for example. And C, the limit from part A that exists has to equal the function value from part B that exists. So each of those things happens in different, or fails to happen in different ways. Let's draw some quick examples of common ways that a function can fail to be continuous. There's this kind of discontinuity, which is called the jump discontinuity. There's functions like this. What function looks like that? Think about it real quick. 1 over x. Or functions like this. What function is like that? How about 1 over x squared? And those are called infinite discontinuities. And then another kind of function that's discontinuous is like that, or like this, with a dot there. And those are called removable discontinuities. Because you can make the function continuous at that point by just redefining the function at just that one point, and then it'll be great. It's interesting to think about which of these things hidden in the definition relates to which of these prospects. So think about each one. Is it more of an issue with A failing, or with B failing, or with C failing? So pause the video, think about that. All right, welcome back. So here, the limit does not exist because the two sides are different. So this is a problem with A. How about here? The limit does not exist because it's shooting off to infinity. And the function value at x equals 0, for example, does not exist. It's undefined. So these are both A and B issues. Here, what's the issue with one of these? It's that the function doesn't exist. If we say, here's the horizontal location A, for this one, the function value does not exist at A, so that's a problem with B. And here the function value does exist, but it's not equal to the limit from both sides, so that's a problem with C. You can have mixed cases where it's infinite discontinuity on one side of A and removable on the other, but we're not going to worry about that. I think people call those mixed.